Hello folks, and welcome to Finding All Zeros. You need your notes, a graphing calculator, which is your phone, but if you're listening to this and watching this on the phone, then don't be worried or alarmed. I do have a screenshot of the calculator, the graphing calculator, that will come up on the slides as you're taking notes. So no worries if you don't have that available. A pen or a pencil to take notes, and we will get started. So today we are going to be talking about finding all those zeros. So let's review how we find the zeros. Okay, so how do we find our zeros? First, we get a hint to get started. Now, how do we get a hint to get started? That's either by using our P's over Q's or by using the graphing calculator. Okay, so one way, we have to get a hint. The second step is we set up our division problem and we find the quotient. Now remember, the quotient has to have a remainder of 0. That's our smiley face 0. If it doesn't have a remainder of 0, you know you have to keep trying, okay? Then you factor the quotient if possible. Now today and yesterday I did talk a little bit about how sometimes the quotient cannot be factored. So if the quotient can't be factored, you should try solving by square rooting. Oops. There we go, square rooting. Or using the quadratic formula. Okay, so that's our next possibility if we cannot factor the quotient. All right, then you should find and list all your solutions, and don't forget to list all factors as well. Okay, now, how is it different from today as it was yesterday? Well, this is where it is going to be a little different. We have to know what the fundamental theorem of algebra is. Now, you already know what the fundamental theorem of algebra is, but I haven't formally had you write that definition down in your notes. So let's go ahead and write it down in our notes. It says that the number of solutions a polynomial has is equal to its degree. Now, I've said that, so you've all known that's what we always have, is the highest degree is the number of solutions that we have in each of our problems. But I may have not said that it was called the fundamental theorem of algebra. That is what that is called. And the fundamental theorem of algebra is kind of like the Pythagorean theorem in geometry. It's just a huge idea. It's a huge concept. So you have to know what the fundamental theorem of algebra is. Now, so far, those solutions that we have found have always been rational or nice, okay? Now when we're finding all solutions, they're not always going to be nice. So sometimes they will be integers and they'll be nice, or they'll be fractions, okay? But sometimes they're going to be square roots. That means they're irrational. Sometimes you're going to get the same solution twice. Remember, that's a double counted solution or a double root. And sometimes you're even going to get imaginary solutions. So the number of solutions is always equal to its degree, but sometimes the solutions aren't very nice. So that's what we're going to see today. All right, so let's go ahead and do this problem. F of x equals x cubed plus 5x squared plus 4x plus 20. Now, if I was going to do this problem and I didn't know where to start, I could do P's over Q's. But remember, I showed you that shortcut where we can even get a hint from the calculator. Okay, so here's the calculator. Here's what the graph looks like. Now that looks kind of scary because it doesn't look like it has 3 solutions, because this problem is supposed to have 3 solutions. I only see 1 solution. The 1 solution I see is right there, and that looks like at -5. Well, -5 is one of the real solutions. If you don't see the other ones, they're probably going to be imaginary. So, yeah, you're right. Roll your eyes. We're going to have some imaginary solutions here. But what we can do is we can take the one solution we know, which is -5. Oops. Sorry about that. We can take the one solution we know, which is -5, and we can go ahead and find all the other solutions by using synthetic division. So I'm going to set this up as 1, 5, 4, 20. Bring down the 1, multiply, add, multiply, add, multiply again, add again, and we get a remainder of 0, which is awesome. That's what we want to see. And now we're going to take our quotient, which is 1x squared plus 4, and we are going to solve it or factor it. It's not factorable. So if it's not factorable, remember the two ways we can go about solving. We can either try to solve by square roots, or the quadratic formula will always work as well. I'm going to try square rooting because I don't have that extra x in the middle. So I'm going to set it equal to 0. And I'm going to solve by subtracting 4 from both sides. I'm going to square root both sides. When I square root, I need to get plus or minus. The square root of a negative is an I, and the square root of 4 is 2. So my solutions to this problem are the -5 that I used from the graph, and plus 2i and minus 2i. Now, where do I get those factors? Where are my factors for this problem? Well, my solution -5 came from a factor of x plus 5, and the other factor was this quotient that wasn't factorable. So x squared plus 2 is my other factor. Now notice I don't have 3 factors. I only have 2 factors, but I still have 3 solutions. I have to have 3 solutions. All right, let's try another one. All right, here we go. F of x equals 3x to the 4th plus x cubed minus 10x squared plus 2x plus 4. All right, if I don't know where to start, I'm going to use my graph to find a hint. Now remember, when I find an x-intercept as a hint, it has to be a nice, perfect x-intercept. This one is not nice. I can't use that one. That one doesn't look nice either. So I can either use this one or I can possibly use this one. So what I'm going to do is I'm going to go ahead and use this one right here, which is -1, it's -2, because this one's -1, there you go, this would be 2. So 2 is -2, excuse me. So -2 is the number that I am going to use. Okay, I'm going to do that. I'm going to erase this so that I can do all my work here. So it was -2. So I'm going to go ahead and do -2 and do some synthetic division. So I've got 3, 1, -10, 2, 4. Bring down the 3. Multiply, add, multiply, add, multiply, add. Oh, there we go. Got a smiley face. Write this as a quotient. 3x cubed minus 5x squared plus 0x, which we don't need to write, plus 2. Okay? And now what I'm going to do is I'm going to look at this and go, ooh, I have a cubed here. And remember, what do we do when we have a cubed and we can't factor it? We have to do synthetic division again. So what I'm going to do is I am going to take a look at my graph again and take another hint from my graph. And the other hint that looked nice was this one right here. Remember, I can't use hints that are in decimal form because I don't know what they are. So I can't use that one or that one. Okay, so I'm going to use that positive 1 and do some synthetic division again. And go ahead and see what I can get at the end. So here we go. Let's take our quotient again and now use the other good hint from the graph. So 3, -5, 0, 2. Don't forget your placeholder. Drop down the 3, multiply, add, multiply, add, multiply, add. Okay, so I have two solutions over here that I know work, which is 1 and -2. Those factors would be x minus 1 and x plus 2. And now I'm going to take this quotient, which is 3x squared minus 2x minus 2, and go ahead and factor it. So -6 is my a times c. Two factors of -6 that make -2. Uh-oh. Factoring doesn't work. And solving by square roots isn't going to work because I have that x term. So, yep, you got it. Quadratic formula coming right back to you. So we can't forget about the quadratic formula. So I'm going to use the quadratic formula to find the answers or solutions, the other two solutions here. So it's opposite of b plus or minus b squared minus 4 times a times c all over 2 times a, which is 6. I would get 2 plus or minus the square root of 28 over 6. That simplifies into 2 plus or minus 2 square roots of 7 over 6. And I can simplify that one more time by saying these will all simplify to make 1 plus or minus the square root of 7 over 3. And so those are two solutions there. It's 1 plus the square root of 7 over 3 and 1 minus the square root of 7 over 3. Now, you could write it like this if you wanted to, or you can break them apart. Either way, I'm okay with that. And then what was the factor that got us these two solutions? The factor that got these two solutions was the original quotient that we came up with right here. That was that second quotient that we came up with. So these three factors multiply to make our original, and those four solutions, because I have a degree of 4, are those solutions that make this equation true. So that's it for today. We'll see you tomorrow, and hopefully this will go well for you.